All right, so our last section was about exponent rules, right? So that's when we're like evaluating, not evaluating, simplifying, evaluating, all those things. Our next part is about exponent functions, exponential functions, and applying them. So it's actually, let's consider the previous part was like a little brain warm up, okay? So we're going to dive into part 2 of our notes and applications and the activity part. So here we go. Have you guys ever heard of the doubling coin? No? Maybe? Yes. Well, it's usually one of the most commonly used statistical problems. Okay. But suppose that you have a coin whose value doubles every day. That is on day one, the coin is worth $0, right? I mean, worth $1. So at day zero is worth $1. Then on day one is worth $2, and then continues on and on and on, right? What would that look like? Well, let's see. The doubling coin represents an example of what? Anyone? What kind of problem did I just say we're gonna? Exponential. It represents an exponential. Okay. It represents an exponential growth. Okay. Where stop. Okay, it went way faster than I thought. I thought I timed it out to go a little slower, but it didn't. Um, Exponential growth. And so what helps us identify is that our initial value, our day zero is 1. And if we looked at the pattern, we would get that day 2, it would be worth $4. Day 3, it would be worth $8. Day 4 would be worth $16. Okay. When you're trying to decide what function models best represents this, you're looking at what is it changing by? How much is it growing or decaying by? So we would look and see what is our growth factor here, right? How am I getting from 4 to 2, 4 to 8, 8 to 16? What am I doing? I am multiplying by 2. So I'm multiplying by 2 each time. Therefore, 2 would be the what of our exponential model? The growth factor, but in the function itself, it would be the what? The b, it would be the base of your model, right? So our function would be modeled by, I skipped a page. Hold on. Why is it going so fast? Oh my gosh. Okay. Again, that's cool. So we end up with exponential function, and the function is going to be a times b to the x, where x represents the days of time. Your initial value is a equals 1. Your base is going to be your change factor. How are you changing by, right? And we're changing by a factor of 2 every single time. I wonder if there's like a setting for the. All right, so we're going to talk about the key characteristics of this function and what it would look like for our problem. All right, I may have made it too slow, but the graph would start at y, the function would start at y times 2 to the x, and it's going to always be positive because the graph is increasing, right? Quickly. Our domain would be from 0 to infinity, and the range would be from 1 to infinity. And the reason why it's at 1 is because money starts at 1, the dollar value. Okay. Are you ready? Okay. So going back to our application here, since we know that this is a doubling model, we know that the equation y times 2 to the x, if we want to figure out how long will it take for us to have $1,000,000, we would take that 1 times 2 to the x and set it equal to 1,000,000. And then you would figure out, um, is it better for them to give me $1,000,000 up front, or to just keep this coin and let it double every day in value? It all depends on how long it takes, right? Like, depending on what you're trying to do, what you're trying to get. And that's what we would be working towards solving. So what you're going to be working towards solving, which is better? Is it better for me to, hey, give my bill now? Or you know what? I'm going to coast it. I'm going to chill. And that's going to be our end game for the notes. Does that make sense? All right. But before we start in the creating, we're going to talk about key things. So key things that have to be true. Your base has to always be greater than 0. Your exponent is your independent variable, which is typically going to be your time. Your initial value is going to be your value at x equals 0. And your growth factor is when your b is greater than 1. So it's your 100% plus your percent change. Your decay factor means it's going to be between 0 and 1. These are things that we should have left 3A.1 being fairly confident. Okay. On the next part of the notes, it's going to be group practice / understanding. So to make sure that you understood what we went through, what we wrote down, you're going to basically re-answer questions as a group. So when you look here, it says group practice part 1. What is the function that we're using to model this with? Then you're going to create a graph of what's taking place. You can create a graph by creating a table yourself, which we already have. We have the data for the table, or feel free to have Desmos help you create your graph. And then you're going to then figure out a way to figure out how long it'll take for you to have $1,000,000. Okay, so we're going to start here on the group practice, and then I'm going to come around with part 2 so we can continue. So I'm going to give you roughly 6 minutes within your group. Talk about, look over our notes, create a graph, and then determine the $1,000,000 status. You can't put it in. All right. Group 1, what was my equation? What was my equation? Exactly. Y equals 1 times 2 to the x. That's because it's simply just doubling. I could construct the graph from the table, from our values that we already had, right? I'm going to spread mine out just so I can have spaces to count. 1, 2, 3, 4, 5. And then we knew that at 0, we started off at 1. At 1, we start off at 2. At 2, we're at 1, 2, 3, 4. At 3, we're at 1, 2, 3, 4, 5, 6, 7, 8. And then at 4, it keeps going, right? We're going to keep going and going and going and going, right? Now the question says, how can we use this function model to decide when to choose the doubling over single payment of $1 million? Okay, so on your graph, we're going to go look at the graph. So essentially, we want to know when y equals $1 million. Need another 0 there, don't I? Yeah. So let's go look at our graph. So I'm going to go to our, well, I have a bookmark, so I'm going to click on the bookmark. So our function that we have y equals 2 to the x. And we want to know, when does y equal 1? Is that enough zeros? $1 million. So in Desmos, when you're doing this, if you know what your y is, you can't use the table. If I click here, notice I can't use my table, right? I can't type in y values. I only can type in x values. Could I sit here and guesstimate an x value? I go, okay, I'm going to put in 100. Okay. Oh, okay. It did that for me. But is that the same thing as, does anyone want to guesstimate the values? No. Simply all you're going to do, though, is just put in what your y equals. Close that out. I know I want y to equal 1 million. Now, I don't want to zoom all the way out to 1 million. Don't want to keep doing this, but you could. You can zoom all the way out to 1 million and see what happens. But you also could go over here to your tool and say, I need to be able to go all the way up to when y is $1 million. Okay, y'all are not a fan of Austin Powers. So 1, 2, 3, 4, 5, 6. Is that 6 zeros? Switch you to 0. You don't even need to be over there. 0. And you can be also at 0. And you can count by this right here. It's called your step. It's like, what do you want me to count by? You can count by 1,000. So I can adjust the window to be able to see what I need to see. So if I want to know when y equals 1,000, I'm in 1 million. Here I am. Founder. So what does this mean? How long would that take me? This would be, what does that 19.9 represent? Days. So the question is, could I wait 19.9 days? Or would I want my $1 million? I don't know. It depends on your life. Is someone after you? Do you have like a hospital bill? Like, huh? Yeah. So that's what it comes down to. But do you see how, using the function that we have, are we able to still calculate and find values from our graph? Yes. What our next unit is about is going to be how to do it without a graph, how to solve it algebraically. But with a graph, are we able to do it? If I give you an exponential function and I'm looking, and here's your output, could you use your graph to find your input? Was this terrible to do? Oh, what made it terrible? Typing the million, counting out the zeros. Yeah, that does get a little hard. But you do have to adjust. Obviously, your numbers won't be as high as 1 million, but that's the gist of it. Okay? How do you feel? I can't help terrible. Gotta get more specific. I'm a little concerned about blah, blah, blah. Which part? Oh, okay, good. If you were, I really want to make legitimately help you. All right, so that's the part one was using computer. Now, to make sure for the rest, we're going to try. On part two, I came around as a half sheet. And now these are different values. So to make sure that you are comfortable using and navigating what we just did, there's practice for you to do. No, part three or part two? Yeah, I gotta update it. I changed some stuff.